Well, good afternoon, everybody. My name is Bree Arthur. I am the president of IPPS Southern Region. I want to thank you all for attending the Charlie Parkerson Virtual Student Research Competition today. True to our motto, to seek and share, we aim to engage and educate plant professionals around the globe. And today's student sessions are sure to introduce valuable ideas as they are truly the future of the horticulture industry. If you are not currently a member of IPPS Southern Region, please visit our brand new website to learn more about all that we have to offer, including free student memberships, scholarship opportunities, and the Early Career Exchange Program, which we will be learning more about later this afternoon. Today, we have an exciting lineup of research papers and presentations. This entire event will be available to watch through the proceedings page on the IPPS Southern Region website with free access to members at any time. Before we get started, I would like to take a moment to thank the hardworking volunteers whose vision has made all of this possible. Thank you to Dr. Cheryl Boyer of Kansas State University for hosting this event and for sharing your expertise on digital communications. Cheryl and I talk on a weekly basis, and honestly, it's like the greatest pleasure of my entire career to get to work with Cheryl, and I deeply appreciate all that you do for IPPS. And I'd also like to thank our long-standing student competition chair, Dr. Mac Thetford. Your dedication and professionalism is a true inspiration. And on behalf of everyone in IPPS Southern Region, I want to extend our sincere appreciation for all that you have done for so many years in making this a reality. The annual student competition is a highlight of our annual meeting, and it plays an important role in our outreach and recruitment for new members. Thank you from the bottom of my heart, Dr. Mac Thetford, for keeping this going. And finally, a quick thank you to the sponsors whose support has made this possible. We have international sponsors, Ball Horticulture and Harrell's Fertilizer, and North American sponsors, Bailey Nurseries, Bayer, ICL Osmocote, Nursery Supplies, Spring Meadow Nursery, and Star Roses. Additional thanks to our more than 30 Southern Region sponsors, who I'm not going to list off, for all of your continued support. We are very fortunate to have long-standing industry relationships, and we look forward to a very bright future. Sponsors, your investment in IPPS Southern Region is greatly valued and appreciated. I hope everyone will learn from today's student research presented. Questions can be submitted through the chat box at any time, and the presenters will be available to field inquiries following each of their sessions. Without further ado, I would like to introduce Dr. Mac Thetford, who will take us along on our student research journey today.
Well, thank you, Bree, for that wonderful introduction. And I must say that this program does not happen without the added support of the many members of IPPS. And they'll tell you I'm very quick to send an email that says, I need your help. And they always reply. So just as a reminder, the competition is composed of two parts. The first step is the evaluation of the student papers, and that's done by a panel of judges who are members of the Southern Region IPPS. They represent academics that are involved in teaching, research, and extension, also propagators, owners, growers, and green industry professionals. Based on the initial evaluations, we have two groups of papers that we are going to be presenting today. We have the papers that are selected by the judges as the top three for 2021. These three students will each have 20 minutes today to present their work. Their presentations will be judged by, again, a group of IPPS members, and they are, the students are competing to determine what level of cash prize they will be awarded in this oral presentation portion of the competition. All three students are competing equally for this portion of the competition because we do not use the initial ranking of their papers in evaluating this portion of the competition. Again, each of these students will have 20 minutes to present their work. These students will not take questions during their presentation, and there will be a question and answer session after each student's presentation. The next group of students would typically get a travel support to attend the meeting, and they would present a poster. In this online format, these students have an opportunity to make a 5-minute presentation on their work. And again, they will not be taking questions during their presentations. We have 3 students, each making a 5-minute presentations. They will be available in a combined question and answer session after all 3 speakers have made their presentations. I will introduce these students as they work with Dr. Boyer to get their presentation set up and share their screens. So we're going to begin today with the 3 5-minute presentations. And again, remember to please keep your microphones muted so we can hear the speakers. Do a little magic on my computer here so I can see what I've typed. All right. Our first speaker today is Christopher Cristioni, and he's going to correct me if I misspelled or misspoke his name. Christopher is a graduate student working on a master's degree at Louisiana State University. He's originally from the Jersey Shore and completed his undergraduate degree in upstate New York at SUNY Cobleskill, studying plant sciences. Currently, he is studying with the School of Plant, Environmental, and Soil Sciences, studying soilless substrates stratification. Ultimately, he would like to work for a university and conduct research, work with the industry, and teach students. He is excited to be headed in the direction to accomplish those goals. And the time is yours, sir.
Awesome. Thank you. Let me share my screen. Okay, can everybody see my presentation?
Yes, full screen, ready to go.
Good. Well, I appreciate you listening to my presentation. I'm going to share with you some of the results of a study that we conducted about a few months ago, where we explored water movement through stratified substrates. Sorry if it's a little slow. So freshwater is a finite resource, and this is a fact recognized by all. We know that our freshwater availability is steadily declining, and nurseries can use upwards of 71 cubic meters per day irrigating their crops. The reason why nurseries use so much water is because we grow plants in soilless substrates. Now, these soilless substrates provide optimal growing conditions. However, these soilless substrates are highly porous. And what I mean by that is they allow for ample drainage and aeration occurring throughout the container. And it's a result of these physical properties that we have to frequently irrigate, where we will irrigate the container, water will quickly infiltrate through the container profile, and only little will be retained, which requires us to repeat in irrigation. And we see on the figure on the left is a dramatized depiction of a moisture gradient within the container, where due to gravitational forces, it's often drier in the upper half and wetter in the lower half. So this imposes the question, what if we place a substrate that really retains water well, where water is quickly lost? And conversely, what if we place a substrate in locations within the container where water often sits, that the substrate can allow for ample drainage to occur? And we can do this, and we did this through soilless substrate stratification, where soilless substrate stratification is essentially the stacking or layering 2 unique substrates within the container. In the upper 50%, we have fine particles or fibrous amendments that are engineered to retain water and mineral nutrients while allowing for more lateral redistribution of water, enabling for a more uniform wetting front. We have the stratified interface at exactly half the container height. And in the lower 50%, we have coarse particles that were designed to improve gas exchange and drainage. I presented a moisture gradient in a traditional nursery container a few slides ago, but we believe that these two stratas, retaining water in the upper half, draining in the lower half with these unique particle sizes, allows for a more uniform moisture gradient throughout the container. So this experiment that we conducted, we had two substrate treatments, a stratified and a non-stratified system, and we placed tensiometers in the upper and the lower half of the container. And what a tensiometer measures is essentially how strongly water molecules are adsorbed to a particle surface or the tension of a substrate. And we wanted to see how stratified substrates influence these tension fluctuations that are occurring in the container under different irrigation scheduling. So we irrigated the containers once a day, and we also wanted to fractionate that irrigation and irrigate a cyclic application where we irrigated it 3 times daily. So this is the tensiometer data, and I know there's a lot going on in this graph, so let me walk us all through it. We had fallow containers, and on the y-axis depicts our tension. And tension is a negative number, so any increase you see on the graph is when the substrate is getting wetter, and conversely, any decrease you see is when the substrate is getting drier. The blue line represents the top strata, and the red line represents the bottom strata. And we could see that in non-stratified systems, we have these large tension fluctuations that are occurring in the upper half. And remember what I said, in the upper half of the container, it's often drier. So this was predicted. And often in the lower half, it's wetter. So this is why in the lower half of the container on the top left of the graph, in a non-stratified system, we see that the bottom half doesn't really have these large fluctuations like the top half does. And we were able to further reduce these fluctuations in non-stratified systems with cyclic irrigation. However, in the stratified systems, we greatly reduce these oscillations that are occurring. So what we can take from this study is that we could possibly provide the rhizosphere with optimal hydraulic characteristics and reduce the energy required for roots to uptake water. And we see further confirmation of cyclic irrigation when we pair it with stratified substrates and the benefits that come from it. Thank you for listening to my presentation. I appreciate it.
Thank you, Chris. And we look forward to having a few questions for you in a moment. So our next speaker is Ping Yu. Ping recently graduated with a PhD in horticulture from Texas A&M University under the direction of Dr. Meng Meng Gu. Her PhD research focused on using biochar as a way to increase environmental friendliness for potted plant production and disease suppression. Now Ping is working as a postdoctoral research associate at the University of Florida at the Mid-Florida Research and Education Center, focusing on weed management in nurseries and landscapes. Her professional goal is to become a professor at a land-grant institution. And Ping, please present your paper. Thank you.
Okay, I'm sharing my, can you guys see my screen?
Yes, can you go full screen? We can.
Yeah, of course. Oh, sorry.
Do swap displays.
How about this? Like, okay, sorry about that. I am going to take, I guess I'll just do this one so that it won't mess up with my presentation. Okay. Why it's still like.
Okay, hit swap displays at the top.
This one?
It was on the other screen, the one that was black and it showed your presenter view.
Okay, gosh.
There's a button in the upper left-hand corner. Not on that one. It was on the previous one that was black.
Ooh. Oh gosh, I'm so sorry about it. I totally forgot that I have 2 screens. It will mess things up. I'll just
It's okay.
You know what? I'll just take this out so that it won't be okay. Sorry. Okay, now I guess now you can see it, already, right?
There we go. Perfect.
Oh, perfect.
Ready to
Sorry
go.
about that. Okay, thank you for the introduction. My name is Ping, and today I'm going to talk about using poinsettia and pepper as model plants to investigate biochar and trichoderma suppression effects on plant diseases. First of all, why do we care? And then we know poinsettia and pepper plants are both very important crops in horticulture. However, their productions are significantly challenged by poinsettia root rot and pepper blight caused by PCM affetidamatum and Phytophthora capsaicii. Those two pathogens are both widely distributed worldwide, and they can easily grow and reproduce under greenhouse conditions. So in that case, we were thinking, can biochar be a possible solution to address those challenges? As such, our objective of this study are to test if biochar and trichoderma can actually reduce those two pathogen growth and test one of the possible mechanisms of how biochar can reduce them. Here, the picture is the sugarcane bagasse biochar and mixed hardwood biochar that we used in this study. We conducted a greenhouse study to test the objective one. We measured disease severity, disease instance, and error under disease progress curve based on those formula here. Here are the 0 to 4 scales that we used for the disease severity rating for PCM and Phytophthora respectively. Moving on, we also conducted an in vitro study to test the objective 2, and we measured the inhibition rate based on the formula showed here. Similar experiments were conducted for pepper plants. Now let's look at the results. Here are the disease severity figures for poinsettia root rot. If you look at this curve, you will notice that poinsettia plants growing HB20 here remained a relatively low disease severity throughout the experiment, while trichoderma had no significant impact on disease severity. As far as Phytophthora, at day 12 and day 17, plants growing HB50, HB70 had significantly lower disease severity comparing to the control. Again, trichoderma had no significant impact on disease severity. What about the inhibition rate? So those are pathogen growing biochar mended PDA petri dish for after 4 days. And figure A showed that all the mixes had stimulation effects on pathogen growth. However, biochar mended mixes had significantly lower stimulation effects on PCM. With trichoderma, all the mixes inhibited pathogen growth. As far as Phytophthora, without trichoderma, all the mixes already inhibited pathogen growth except HB10. With trichoderma, all the mixes inhibited pathogen growth. To conclude, our study showed that biochar can reduce PCM and Phytophthora disease, but the chemical compounds in HB may not suppress PCM, but it does suppress Phytophthora. That means our study can save grower more than $10 billion annually for poinsettia and more than $200 billion for pepper if we're using biochar to produce them. I would like to thank all my committee members, and with that, I'd like to take any questions you may have.
We'll wait until we have one more speaker, and then we'll have everybody together. Thank you very much, Ping, for your presentation.
Yeah, sorry about the time.
No problem.
Spent on that. I'm sorry.
All right, our next speaker is Runshi Z. He is a PhD candidate in the Department of Horticulture Sciences at Texas A&M University. He has always been captivated by the biodiversity and improved well-being that plants bring to individuals since he grew up in a subtropical city located in Southeast China. His childhood experiences led to his passion for nature and science. He started his undergraduate study in landscape architecture, where he was exposed to both nature and plant sciences. Later, he joined Texas A&M University, where he earned a master's degree in the area of plant breeding. Rinchi is currently working on a multi-state, multidisciplinary project to combat crepe myrtle bark scale and introduce pest species in the United States. He's been confirming and evaluating the potential threats of CMBS to other important or native crops in the US. And his current life table study aims to improve understanding of insect biology, such as the life cycle and mating behavior, ultimately creating integrated pest management programs for this insect. So with no further ado, please present your work. Thank you.
Hi, is my screen looking okay?
Yeah.
All right, thank you, Dr. Thekfor, for the great introduction. And my name is Rinchi, and today my topic is the identification of new crepe myrtle bark scale hosts through DNA barcoding. Let me get my pointer. All right, so to begin with, crepe myrtle is a very popular plant in the southern eastern of United States. And there are a lot of different cultivars with different flower colors and wonderful plant architectures. It is also a great source of pollen that is supporting the local bee population, which makes it an important component of the local ecosystem. However, I'm here to report the bad news. The crepe myrtle bark scale, which is basically a plant parasite that infects crepe myrtle, and this is what a typical infestation looks like. So as an invasive pest species, the crepe myrtle bark scale was first discovered in the United States in 2004 in northern Texas, and it has been reported in at least 16 other states so far. And what's even more unfortunate is that not only crepe myrtle is susceptible to this insect, but there's also other alternative hosts. For example, soybean, which is another important crop in the United States, has been reported as one of the alternative hosts of crepe myrtle bark scale according to the previous literatures. And therefore, our research team has been conducting study to evaluate the potential threat of this pest to the United States. And here is the result of one of my published study from last year, which would confirm a few more alternative hosts of crepe myrtle bark scale here in the United States, such as apple, common persimmon, and pomegranate. And as you can see here, all the number of crepe myrtle bark scale on these plants are relatively low compared to the infestation that you can see on crepe myrtle, which means the risk of these plants are relatively low. Well, does that mean we are safe? And the answer is no, because naturally occurring infestation has been reported in the field. So on the picture on the left here is an infestation that's found on American beautyberry, which is a native species. And the middle picture shows an infestation that's reported on a native Hypericum. And the picture on the right here is actually an infested stem of Spirea thurbergii. So now you might be wondering, how can we be sure that these random infestations were indeed caused by crepe myrtle bark scale? I mean, they do look similar, but there are so many scale insects. How can you be sure? Just like crocodile and alligators, they might look similar, but they're actually different species. So that's why we actually use molecular approaches to confirm species. So basically, we can extract very small extract DNAs from a very small amount of insect samples, and by doing DNA sequencing technology, we can obtain its DNA sequence. And by comparing and analyzing the sequence data from different samples, we can actually figure out what's the true identity of a species. So for example, by doing a DNA analysis, we can get this kind of phylogenetic tree, which will be able to indicate the genetic relationship of different insect samples. The red box here is actually showing all the samples that was collected from United States location. And all the samples from Asia location has been grouped into this blue box. And this green box is showing all the other species which are the close relative to crepe myrtle bark scale. And as you can see, the alternative hosts the samples from alternative hosts is actually grouped together with this US location, which indicating that they are truly Quemodo bar scale. Now, this kind of information or confirmation is important because it allows us to better assess and evaluate the potential threat of this invasive insect to ecosystem as well as the horticulture industry in the United States. For example, through our host range confirmation studies, we found that a lot of these alternative hosts of Quemodo bar scale actually belongs to the family of Rosaceae, which is an important family of many other economic crops, like such as apricot, almond, cherry, and peach, right? So for our next step, we will be studying the potential damage of Quemodo bar scale that can cause to these other important plants and hopefully keep our industry safe. Thank you for listening to my presentation. I really appreciate it. If you're interested in this topic, here's my contact information. Thank you.
Well, thank you very much. At this point, Cheryl, I don't know if you're able to put more than one student up on the screen, but we will entertain questions for all three of our
Where did you
speakers
go?
at this point.
Christopher, there you are. Wait, why can't I add you?
You can take me off if you need to add him.
No, I don't think that's a problem. Hold on, go ahead, y'all, with your questions. There you are. You jumped up to the front now. Okay, there we go. I know you have questions. You wouldn't be IPPS members if you didn't.
If you don't mind, I have a question.
Absolutely.
Hey, Christopher, that's a great presentation. I enjoyed it a lot. I will have just one quick
thank you.
question. Do you have you measured the volume of the water that you can save by doing the stratification versus the non-stratification way?
We did not quantify how much water we have saved. However, in another study, we grew plants in an open air nursery production pad, and we implemented deficit irrigation, and we were irrigating the crops 3 times a day, but only 1 minute per irrigation. And all plants grown in a non-stratified system actually died, and our plants grown in a stratified system continue to grow just as normal. So we were able to reduce our water inputs and continue to produce a crop.
Thanks, that's very nice. Thank you.
Yeah.
I have a
Anybody
question,
else?
if you can hear me.
Yes.
I got a question about scalability and the commercial operation. You did this at a nursery location, and how adaptable to the process of using the 2 different media in a mix. Was that something you discussed with the individuals that you did your research with there at that nursery? And then anything else that you might come up with as a forward-looking statement?
Wait, I'm sorry. Can you repeat that? I had bad connection.
No, I'm the bad connection. I'm sitting in my vehicle. So the point is, how scalable is this in a commercial operation to do the 2 different media mixes? Have you had that discussion with the nursery that you performed this location? And again, what you think on a possibility on a automation system of being able to do this, because I think it's a great idea and it has a huge merit for the.
Yeah, so that is the next logical step into identifying and how efficient this is in nursery production. We believe if some nurseries have a 2-hopper system where a container could go on a conveyor belt, fill up half of the substrate, continue moving on the conveyor belt, and then fill up the other half, we believe it will be efficient. But no, we have not conducted any studies yet determining the efficiency and the time it takes to actually quantify in a nursery setting.
I don't think you have people lining up to try this. So that's
I
good.
hope so.
Chris, I know you didn't grow any plants in this study, but you kind of hinted that you have in other studies. How do the roots perform differently in each of the different substrates?
Yeah, so we actually, this study that I just presented was the beginning of an overall study where after we conducted this, we actually transplanted plants and we measured the tension fluctuations and volumetric water content when a rooted system was present. And the rooted system actually resulted in an increase in fluctuations in the upper half due to evapotranspiration and root uptake. In the study that I mentioned before, how when we imposed water deficit conditions, the root system of the root system of stratified systems actually grew better than non-stratified systems as well. So we had enhanced root growth in stratified systems.
Excellent. Did the root ball fall apart? You know, when you removed it, did you notice any difference that way?
We used lower pedalum in the study in the open air production pad, and then we used dianthus in this study that I presented today, and both have fragile root systems. So it was a little difficult to harvest the roots. However, the root systems did seem more hardy and resilient and stronger.
Thanks.
Christopher, I have a question for you.
Sure.
I agree with Jim 100% on that. If we can figure out how to scale this, that this could be something that a lot of people would be interested in. But it's not only the scale. So many of us use one type of bark and add different amendments to it. What are the figures on the cost difference per yard for the two types of barks?
So we didn't buy the bark separately. What we did was we screened it ourselves. But we also, you mentioned like fibrous amendments. We also, in another study, we had a peat moss and a coconut coir where we amended just regular conventional pine bark by a 3-to-1 volume ratio. So all of our substrates we produce ourselves, and I do believe that that's also a next logical step into studying to see the cost differences of coarse bark or fine bark or coarse bark and bark amended with peat moss and so on.
Or more importantly, the availability of it. A lot of bark suppliers, this is the type of bark they produce. I think it's valuable, but I think that digging into the details on the supply chain would really benefit it, because I can tell you, we're processing hundreds, if not thousands of yards of bark at a time.
Oh yeah.
I don't have time to sift that.
Yeah, that's a very, very good question. And I will certainly have to look more into the difference in cost and, like you said, availability.
I have a question for Ranshi. I was interested in knowing if you were able to quantify any of the rates of reproduction of this scale on the alternative host, or if you have any idea that any one of these alternatives might be a stronger, potential bank of the source material.
Thank you for the question. The answer is I haven't been able to do any evaluation on the fecundity of the scale on these alternative hosts yet, but that will be definitely a interesting study to do. But I would say that for infestation on these alternative hosts, especially the spirea that I show and the American beautyberry, they all have very severe infestation, just visually, because previously for my host range confirmation studies, we tested some alternative hosts, but it's almost relatively low compared to the typical infestation that you can see on grey myrtle. But for this naturally occurring infestation. To start with, this naturally reported infestation that has to be very severe to cut people's attention, and they will be reported. Hopefully that helps.
Great. Well, I think we've run out of questions or time for questions on this session. Clearly, there's a lot of interest in all of this work, and I would encourage all of our members to take advantage of contacting these students if you have more questions or some ideas, or might want to give them some encouragement on the projects they're working on. Thank you all. We appreciate your participation, and hopefully we'll see you again in another year. All right.
Count on it.
At this point, I'm going to hand it back to Bree for just a moment, and I will be right back.
Well, thank you, Christopher, Ping, and Runchi, for your excellent paper summaries. That is a lot of great information that you're working on. We are so pleased that you could participate this year and share your knowledge through IPPS Southern Region, and we hope you will plan to return next year. Now, you all might be wondering, when will the winners actually be announced? And we are thrilled to finally have the opportunity to meet in person once again during our upcoming annual meeting in Mobile, Alabama, October 23rd through the 27th. The 3 finalist research paper winners will be announced during the awards banquet on Monday, October 25th, starting at 7 p.m. Eastern. The full award session will be live streamed through the IPPS Southern Region Facebook page, and the awards will ultimately be mailed out to each of the recipients following the annual meeting. Now, in 2022, we will welcome back the student competition as part of our traditional educational sessions during the annual meeting that will be held in Athens, Georgia on October 17th through the 20th. Mark your calendars now and note that these dates are slightly shifted to accommodate the SEC athletic schedule. Yes, we had to change our IPPS schedule because of football. The 22 meeting will be held in Athens starting on Monday and concluding on Thursday. And I see Mac is back at his post. So now to introduce our 3 student presentations, back to Dr. Mac Thetford.
Thank you, Bree. This next section of the program represents the 3 students competing for the cash awards. Each student will have 20 minutes to make their presentation. And again, I would encourage you to watch the backdrop behind you or behind Dr. Boyer. And that will help you understand where you are in your timing. Each student will have their own question period immediately following their presentation. Our first presenter today will be Anthony Bowden. Anthony is graduated from Auburn University with his bachelor's in agronomy and soils and a master's in horticulture. Currently, he is a PhD candidate at Mississippi State University, where his research focuses on evaluating new adjuvants and production methods for commercial plant propagation. After completion of his degree work, he seeks to join academia and continue conducting research that benefits our nursery owners and educates the next generation. The title of his paper is Evaluation of Surfactants for Use in One-Time Foliar Auxin Applications in the Propagation of Woody Ornamentals. Anthony, the floor is yours.
Thank you, Dr. Thetford, for that introduction. So plant propagation is a highly labor-intensive process, and the availability of labor is the main factor affecting our nurseries and our greenhouses today. Current methods of applying root-promoting compounds can result in a wide variability in rooting. Therefore, the development of alternative application methods can lead to both increased labor efficiency as well as rooting uniformity. U.S. sales of horticultural crops totaled $13.6 billion in the year 2019. And the 10 states you see highlighted in green on this slide accounted for 66% of those sales. Further, the sales of nursery stock in 2019 totaled $4.5 billion. That's an increase in 7% over the value reported in 2014. Further, propagated horticultural materials, bare root liners, and unfinished plant materials totaled $720 million. And that's an increase of 4% over the value reported in 2014. Horticultural operations expenses totaled $11.6 billion in 2019. Of that $11.6 billion, labor accounted for $4.8 billion. That's 42% of nursery budgets were in labor. Now, auxin was the first plant hormone discovered, has been given the name as the master hormone, as is a key component in many plant physiological actions. In 1935, we saw the discovery of 2 synthetic auxins, indole 3-butyric acid, or IBA, and 1 naphthalene acetic acid, or NAA. Synthetic auxins are more widely used for adventitious root formation due to their stability to both heat and light degradation. Rooting trials using IBA and NAA marked a turning point in commercial plant propagation. In plant tissues, auxin moves in a polar direction. This simply means that auxin moves from where it's produced, in this case the leaves and the apical meristems, down to the roots for storage. And currently there are 2 primary methods for applying root promoting compounds. And those 2 methods are the basal quick dip method or the talc method. Depicted in this image, you can see workers applying hormone to cuttings using the basal quick dip method. Previous research into foliar applications of auxin has shown that one-time applications are the standard. When using foliar applications of auxin, much lower concentrations are used when compared to the current conventional method. Overhead applications are increasing in use throughout the nursery industry. Previous research has shown, nursery owners I've noticed that have made the switch have seen a decrease in both their handling as well as their storage times. As a result of that, their propagation process has become much more streamlined. By eliminating the need to perform a basal quick dip to treat cuttings with auxin, the potential for cross-contamination has also been eliminated. Previous work on foliar applied auxin has concluded that further work is needed on auxin formulations, application methods, as well as the use of surfactants. So depicted in this image, you can see a worker applying auxin in a foliar manner to a bed of cuttings. However, foliar applications of auxin are not without their issues. One-time applications are not sufficient for some woody plant species. In this case, nursery owners use multiple applications to supply enough exogenous auxin to promote adventitious root formation. And these multiple applications lead to increases in chemical costs. So why not use surfactants for propagation? Surfactants are already commonplace in agricultural production, as the effectiveness of foliar applied chemicals solely depends on its ability to be translocated to that site of action. And surfactants act by reducing the surface tension and increasing that droplet to leaf ratio. Research has shown that foliar penetration of NAA is increased when co-applied with a surfactant. And the addition of potassium to leaves with a surfactant showed an increase in leaf transpiration. The objectives of this research was to determine if the addition of surfactants to water-soluble auxin solutions increased the rooting response when compared to the current commercial standard. For this study, we used either 3.3-inch or 4.5-inch square production pots filled with a 100% pine bark propagation media. And these flats were placed under intermittent mist during the daylight hours, and that mist interval was adjusted as needed throughout the study's duration. For this study, we looked at two plant species, the first being Camellia japonica, or common camellia, and the second being Magnolia grandiflora, southern charm, or the teddy bear southern magnolia. Our experimental design was a completely randomized design with an augmented factorial treatment arrangement with 15 cuttings per treatment. A mean separation was performed using the Holmes simulated method within the SAS statistical platform. For this study, we looked at 2 surfactant concentrations. The first being a no surfactant control, and the second being the label rate, which is 0.85 parts per million regulated. That was used in conjunction with 4 foliar applications of either 0, 500, 1,000, or 1,500 parts per million IBA. And these were compared to the current commercial standard basal quick dip of either 2,500 parts per million for Magnolia or 4,000 parts per million for Camellia. At study's termination, the following data was collected: rooting percentage, root number, shoot height, the average length of the 3 longest roots, and a root quality rating from 1 to 5, with 1 being a cutting with no roots and 5 being a cutting with 10 or more roots. In addition, a Lycor 6800 portable photosynthesis machine was used to collect net photosynthesis as well as the model conductance values. Now, presented in this table are our results for our propagation study with Camellia. On the left-hand side of the slide, you will see rooting percentage, followed by root number, then the average length of the 3 longest roots, then shoot height, followed by root quality rating, then net photosynthesis, and finally stomatal conductance on the far right-hand side of the table. Since the interaction between surfactant and auxin rate was found to be non-significant, only main effects are being presented. Both surfactant and auxin rate were found to be significant for root number. Surfactant was found to be significant for the average length of the 3 longest roots, as well as for root quality rating, and finally for net photosynthesis. Little computer trouble there, sorry. So before I begin, let me set up this figure. On the x-axis, you will see the surfactant concentration, either no surfactant or a use of regulated. On the y-axis, you will see the tested rooting parameter, in this case, root number. The bar colors will not change for the remainder of this presentation. For root number of Camellia, the use of regulate resulted in greater root numbers than cuttings not treated with regulate at the time of treatment initiation. Further, the use of a 4,000 part per million quick dip resulted in greater root numbers than cuttings receiving either a 0, a 500, 1,000, or a 1,500 part per million foliar application of IBA. Cuttings receiving regulate had on average 2 centimeter longer roots than cuttings not receiving regulate at the time of treatment initiation. And cuttings treated with regulate had a greater root quality rating than cuttings not receiving regulate. However, cuttings not treated with regulate had a higher net photosynthesis value than cuttings receiving regulate at the time of treatment initiation. Now, presented in this table are the results of our propagation study with teddy bear southern magnolia. The layout of this table is identical to the one previously described for Camellia, so for the sake of brevity, I will only be talking about significance. Like Camellia, the surfactant and auxin rate interaction was found to be non-significant, so only main effects are being presented. For root number, auxin rate was significant. Surfactant and auxin rate were significant for both shoot height as well as root quality rating. While rooting percentage was not significant for Magnolia, April cuttings of teddy bear magnolia treated with regulate rooted at 73% rather, and cuttings receiving at least a 1,000 part per million foliar spray or a 2,500 part per million basal quick dip resulted in greater than 50% rooting. Now, cuttings receiving either a 1,500 part per million foliar application or a 2,500 part per million basal quick dip resulted in greater root counts. The cuttings receiving either a 0, a 500, or a 1,000 part per million foliar application. Cuttings treated with regulate, cuttings treated with regulate had on average greater shoot lengths than cuttings not receiving regulate. And cuttings treated with a 2,500 part per million basal quick dip had greater shoot lengths than cuttings receiving either a 0, a 500, or a 1,000 part per million foliar application. Cuttings treated with regulate had a greater root quality rating than cuttings not receiving regulate. And the use of a 1,500 part per million IBA or a 2,500 part per million basal quick dip resulted in a greater root quality rating than cuttings receiving either a 0, a 500, or a 1,000 part per million foliar application of IBA. For camellia, our rooting percentage was not impacted by either auxin rate or the use of surfactant. And cuttings treated with Regulate had more roots compared to cuttings not receiving Regulate. The use of a 4,000 part per million quick dip had more roots than cuttings treated with foliar applications of either 0, 500, 1,000, or 1,500 parts per million. And the use of Regulate resulted in greater root lengths, greater root quality values, and higher net photosynthesis values than cuttings not treated with Regulate. For Magnolia, our rooting percentage was not impacted by either auxin rate or the use of surfactant. The average length of the 3 longest roots, net photosynthesis value, or a stomatal conductance value were not impacted by auxin rate or the use of surfactant. Cuttings treated with 2,500 part per million as a quick dip or a foliar application of 1,500 parts per million had more roots than foliar applications of 0, 500, or 1,000 parts per million IBA. The use of Regulate resulted in greater shoot heights and root quality ratings than cuttings not treated with Regulate. The use of a 2,500 part per million quick dip resulted in greater shoot lengths than cuttings treated with either a 0, a 500, or a 1,000 part per million foliar application of IBA, and a foliar application of 1,500 parts per million or a 2,500 part per million basal quick dip resulted in greater root quality ratings than cuttings treated with either a 0, a 500, or a 1,000 part per million foliar application of IBA. For camellia, our results suggest that basal quick dip is the preferable propagation method. If you are using foliar applications, the use of Regulate improved on most results. One-time foliar applications are not sufficient to improve rooting responses when compared to the current conventional basal quick dip. For teddy bear magnolia, our best rooting parameters were obtained by using either a 1,500 part per million foliar application or a 2,500 part per million basal quick dip. One-time foliar applications appear to be beneficial for teddy bear magnolia, and the benefits of foliar applications are species dependent. Trials are currently underway looking at different species, as well as examining single applications of foliar IBA versus multiple applications of foliar IBA. Further research can be expanded on looking at other surfactants, and as well as looking at different auxin formulations. I'd like to thank my major advisor, Dr. Patricia Knight, my committee members, Ms. Jenny Ross for her help with statistical analysis, Mr. Scott Langlois and the staff at the South Mississippi Branch Experiment Station, as well as Kalo Incorporated and Hortus USA for providing both the Regulate and the water-soluble salts of IBA used for this study. Thank you, and I look forward to answering any questions you may have.
So does anybody have any questions for Anthony?
Yeah, I've got
I'll
one.
jump in. Go ahead.
This is Martin Vandergeesen. What I'm really concerned about is not the labor savings. I'm concerned about percentages of rooting. Have you looked at the possibility of the combination of foliar application with quick dip? Going ahead and trying quick dip and seeing if foliar applications either speed up the rooting process or increase your percentages.
So the question was if we looked at a combination of a quick dip followed by foliar applications. Is that
Yes.
correct, Doctor? Okay. No, sir, we have not looked at that, but that is a potential avenue for further research.
Thank you.
Thank you.
And I'll follow up on that as well too. My question is, if you had some success with not as good a success as you wanted to have with the quick dip versus the topical spray, but do you see an opportunity for that to continue to expand and become a better option? Because again, labor will always continue to be a problem and continue to grow be a problem.
I'm sorry, can you repeat that?
No.
I'm having a.
ones where you had the quick dip still being the most effective method of okay. Can you hear me at all?
Yeah, I hear you.
Okay. So the research did where the quick dip was better at this point in time. And again, labor will continue to be an issue over time. Do you see an opportunity to improve that either through technique or possibly?
So, correct me if I'm wrong, but this is my understanding of the question. So we do want foliar to be better due to the labor efficiency. So in the areas where the quick dip was better than foliar application, is there a way that, kind of piggybacking off Martin's question, I think further research really should look at a basal, could look at a basal quick dip first and then followed by foliar applications after that. But then again, you still have the labor inefficiency with the basal quick dip. So maybe the multiple applications of the foliar sprays can equal the basal quick dip. And that's kind of what we're hoping with these trials that we're currently working on with other species.
I have a question for Anthony.
That's it.
Okay.
Anthony, Fred Davies speaking here. The communities you worked with had a higher photosynthetic rate when you were working with a surfactant, correct?
Yes, sir.
And what do you attribute that to?
So the question was, why were cuttings of camellia treated without surfactant have a higher net photosynthesis value? And it's my simple hypothesis I have that's the stomatal concentration on the leaf surface. Maybe the surfactant was kind of clogging some of the stomates that prevented photosynthesis from actually taking place. But we don't know. That's just
hormonal effects with photosynthesis and the surfactant?
Fred, your question wasn't clear. Could you repeat it, please?
Sure. I was asking, were there any possible hormonal effects that might have occurred in conjunction with using the surfactant to increase your photosynthetic levels?
So the question was, were there any hormonal effects with surfactant? It is not my belief that there were any hormonal effects with the surfactant. No, sir.
Okay, I think we have time for one more question for Anthony.
Can I have one more question for Anthony? Hi, Anthony, it's Benwell from Texas in the name. That's really interesting presentation. So you determined or tested the effect of oxygen rate on roots and shoots of Camellia japonica, right? But like your slide showed that there was kind of no significant difference on like root quality, photosynthesis, and shoot height, just the roots number, right? So I wonder, like, because you recommended like 4,000 ppm to like improve the results. Could you justify the result? Because if I would be a breeder, I did not see any difference, like good impact on the shoot height, root quality, and photosynthesis. I don't want to like pay more to get the roots.
Right. So I'm sorry, I could not understand your question. Could you somehow?
Sure. Yeah. I mean, You tested the effect of different oxygen concentrations on roots and shoots of community japonica. Based on the results, there was kind of no significant difference on shoot height, root quality, net photosynthesis among the different oxygen concentrations, right? Could you justify that a little bit?
So the question is, well, could I justify the use of 4,000 parts per million for Camellia japonica? And as for root number, yes, the use of a 4,000 part per million quick dip resulted in greater root numbers. And if you're looking at finished liners, root number is more important. Because if it can root in the pot, that is yes. So yes, to improve rooting, the use of 4,000 part per million would be the recommended rate. Yes.
Okay, got it. Thanks for clarification. I appreciate it.
Well, thank you. Well, that will bring us now to our next speaker. Our next speaker is Yuvraj Kamare. He is a PhD student at the Department of Environmental Horticulture at the University of Florida. He completed his undergraduate work at the University of Nagpur in India. His current area of study is focused on weed science and its management in container-grown ornamental plants. His research focuses on developing new methods of weed control by strategically improving the cultural practices used by nursery growers. The goal of his research is to find effective, economical, and environmentally friendly weed management options. After graduation, he plans to work as a successful weed scientist with an agrochemical company or in academia, helping to find and develop new methods of weed management. You're welcome to begin, sir.
Thank you for that awesome introduction. I'm glad to be here, and I'll jump right into it. So everyone can see my slide, right? I don't want to just start talking. All right. So weed management is one of the costly and challenging aspects in container nurseries. Nursery growers spend about $11,000 per acre per year just to manage weeds. And research has also shown us that a single weed can reduce the weed growth by 40 to 60% in just one season. So, and even if the decrease in plant growth was not an issue for a grower, ornamental plants must be weed-free in order to be sold in the market. So to manage weeds, nursery growers rely heavily on herbicides and hand weeding. But herbicides work, but there are several negative consequences associated with herbicides. This includes they are costly, especially for a small nursery, and then they're really difficult to apply on nursery containers. There are limited options available to apply inside a greenhouse or around several ornamental plants. And then they come with several environmental concerns, such as leaching or runoff into groundwater. And along with herbicides, growers rely on supplemental hand weeding. But nursery growers can spend up to $4,000 per acre per year just on hand weeding in containers. And in today's day and time, it's really difficult to find labor itself. So due to the cost of hand weeding and the challenges associated with herbicides, more integrated weed management strategies are needed that would decrease the use of herbicides and be environmentally sustainable. One such strategy is stratifying substrates, or we can simply call it layering to create designer substrates. So the goal here is to determine ideal substrate characteristics needed to reduce weed germination and its growth, while at the same time it does not affecting the ornamental plant growth or its quality. So this idea was first proposed by Dr. Fields, Owen, and Outland, and Christopher really explained it really well before. So what substrate stratification is, it involves layering of different substrates or even different textures of same substrate within a container. So what they did, they used coarse particle substrate as bottom layer and fine particle substrate as top layer, with the goal of improving irrigation and fertilization efficiency. We applied the same method, but we inversed our substrate layers. So the larger particle materials were added to the top portion of the container, and the top portion had no peat, no sand, or even fertilizer, while the bottom layer consisted of standard size substrate with fertilizer incorporated throughout the bottom layer. As a result, the top portion of the substrate that does not hold enough moisture or nutrients for weeds to germinate. So the objective of this study was to evaluate the effect of stratified substrate and strategic fertilizer placement on germination and growth of common nursery weeds. And substrate stratification has shown promise to control weed growth. It is a good non-chemical option. It has shown that it improves the hydraulic properties of a container. And then it has also shown to improve plant growth. So this study was conducted at Mid-Florida Research and Education Center located in Apopka, Florida. The weed species we selected was spotted spurge and liverwort, two of the most common nursery weeds. And for substrate, the substrate consisted of pine bark, which was thoroughly screened to 3 different sizes. And the sizes consisted of particles ranging from 0.3 to 0.6 centimeter, 0.6 to 1.3 centimeter, and 1.3 to 1.9 centimeter. These three particles were used as a top layer, while the bark was also screened to pass through a 1.3 centimeter screen, and this included all fines. So it included anything under 1.3 and anything under. So here's an illustration of how the treatments looked. So firstly, the standard substrate, which consisted of 1.3 centimeter pine bark throughout the container, along with fertilizer incorporated throughout the substrate. And then the stratified treatments consisted of either 0.3 to 0.6 centimeter, 0.6 to 1.3 centimeter, or 1.3 to 1.9 centimeter as the top layer, and this had no fertilizer in it. While the bottom layer consisted of the 1.3 centimeter substrate with fertilizer incorporated throughout it. So, and the top layer for the stratified substrate, it was applied at the depth of either 2.5 or 5 centimeter. So whenever you see TO, that means throughout, that means the fertilizer was incorporated throughout. And when you see S, that stands for stratified. For data collection, we seeded, first of all, we seeded 25 spotted spurge seeds in each pot. And the data collection consisted of weed count, which was done at 4 and 10 weeks after potting them. We also collected the spotted spurge shoot dry weight, which was collected at 10 weeks after potting them, which was at the trial conclusion. And for liverwort, we did the surface coverage, which was done with the help of ImageJ software. And it was done at 20 weeks after potting them. We also collected the substrate physical properties, such as airspace, total porosity, container capacity, and bulk density. And additionally, we also did the particle size analysis. But for the sake of saving time, I'll be just presenting the germination and biomass data in the results. And our liverwort setup looks something like this, where the pots full of liverwort, which were started 10 weeks before starting this experiment, they were used as an inoculum. And they were placed around each substrate treatment at a distance of about 0.5 centimeter. So this way, the experimental pots, the stratified substrates and other substrates, had an inoculum pot on all 4 sides. And here's an example of how the ImageJ processes the picture. It has a tool called color threshold, which we used to measure the liverwort coverage, where it separates the color and tells you the coverage of the liverwort. So moving on to our results. This picture is of spotted spurge, which was taken at 4 weeks after potting them. Here you can see the germination of spotted spurge was high in the stratified substrate, while it was low in most of the stratified treatments. So this is a graph that follows the picture I just showed. For the x-axis for all my graphs in this presentation will be substrate treatments. And in this graph, the y-axis stands for germination count of spurge in each pot. So compared to the standard substrate, the germination was low in most of the stratified treatments, except the treatment of 0.3 to 0.6 centimeter pine bark, which was stratified at 2.5 centimeter. And this picture, looking at this picture, it looks like there's no difference in the growth of, it's hard to tell the difference in the growth of spotted spurge. This is due to its spotted spurge growing pattern. But a clear difference can be seen in this graph. The y-axis here stands for the shoot dry weight of the spurge. It was interesting to see that the growth of spurge was low in all of the stratified treatments that were at a depth of 5 centimeters. And here's an interesting picture of liverwort. The growth of liverwort was none to few in all of the stratified treatments compared to the standard treatment. And this graph again follows the same, the picture I just showed. There was no growth in any of the stratified treatments versus the standard treatment. So overall, spotted spurge germination, spotted spurge decreased, substrate stratification decreased spotted spurge germination by almost 30 to 84%. Spotted spurge shoot dry weight was reduced by 45 to 55 in the stratified treatments when the top layer was at a depth of 5 centimeters. And also the dry weight was reduced by 14 to 42% in the stratified treatments when it was at a layer of 2.5, at a depth of 2.5 centimeters. And for liverwort, as I showed in the picture, the liverwort coverage decreased by 95 to 99% in all of the stratified substrate treatments. So in conclusion, the germination and growth of both species decreased when the substrates were stratified. Stratification also resulted in higher airspace and lower water holding capacity in the substrate. And additional studies have shown that there's no impact on crop growth or its marketability. And this is a good potential option for herbicide-sensitive crops, and it can be used as a part of an integrated weed management program. But for future work, we'll be determining the effect of these strategies on growth of other common ornamental species and problematic weeds in container nursery. And we'll also determine the effect of top dressing on long-term crops growing in the stratified treatments. And we'll study the effect of these methods on irrigation and fertilization efficiency. And we'll also combine this with other strategies with other non-chemical techniques. Thank you for attention.
Thank you. Does anybody have any questions?
I have one. So this is Christopher Brown. Thank you for your presentation. My question is, in a commercial nursery setting, how would you apply the top layer? Are you treating it more as like a mulching application, or are you physically planting the plug into the top layer?
So the question is, how would this be applied to a commercial nursery? So there are machines with 2 conveyor belts that can be used for applying the bottom layer and then top layer. But this is different from mulching, where the plant is applied. Well, the mulch is just on the top. In this stratified treatments, the root is included in the top layer. Of the stratified treatments. So it'll be applied with the help of 2 conveyor machines, where bottom layer is applied, then then the root ball is, then the plant is planted, and the top layer is on top of it. So it's different from mulching, where mulching is not holding the roots. When the pot drops over or falls over, the mulch you lose the mulch. But in this, the plant is growing along with the top layer, so it holds the top layer too.
I was just curious, because it seems like to me when you actually do plant a plant in that substrate, that depending on where you're at, you could argue that it could be a week or months, depending on location, time of the year, until that plant establishes itself to be able to reduce your water inputs. And planting it in the top of that, it seems like that would increase your water use. And then how would that affect your the results that you have concluded to currently?
Correct. Well, we were mostly focused on controlling weed, but we did some preliminary studies with ligustrum and plumbago, which did really good. There was no difference in any of the treatments. Plants grew almost similar in all of the treatments. So it is successful even with the ornamental plants. It's just initially when the weed seeds are growing in. So our goal was to control the weeds when they're growing initially in the pot. Does that answer your question?
Yeah, thank you.
Thanks for the question.
So this is Laura Miller, Texas A&M University Extension. And I wonder if you, I know it would be a pain, but if you could somehow classify nursery weeds as things that would be more likely to be well controlled in the system, because it was just obvious to me that the liverwort needs a lot of water and the spurge doesn't. So, just kind of trialing a whole bunch of weeds or classifying them as things that would work well in the system or not work well in the system.
I would say one thing that a weed with extensive root, like a long roots, which grows extensively, that I don't think that will really work in there.
Okay.
And something that has smaller roots that cannot reach the bottom of the bottom layer easily. That's when it's the weeds struggle, because all the nutrients are at the bottom layer. If the roots can reach there, the weed will grow easily. So that's why there was a great success with liverwort, as there was no water holding capacity at the top layer. And usually weeds grow, like the seeds will fly in, and they need water initially to grow, weed seeds to germinate. So it is blocking most of the water for most of the weed seeds that would be contaminated in the pot. Does that answer your question?
Yeah. I just think you could make a list of, like, if you're in an IPM like system, if you're really having a problem with liverwort or this is a great idea. If your problem is something else, then maybe it's not going to work quite as well.
That sounds helpful. I might do that for my extension for
Yeah.
future work.
So I have a question that might help clarify some of the earlier questions. There are some systems where your transplant might be placed in the pot before the final filling of the pot. And then there are other systems where you might come back along and insert the plugs after the pot is completely full. And I think if you would address those two approaches to planting, you might hit on some of the issues that were brought up in the other questions.
Right. So we did the bottom layer and then had the liner on top, and then planted the top layer on with the plant along with it. So that was our versus with mulching, you would just put the plant inside and top layer with the mulch. So that was different from mulching. I hope that explains the two differences.
Could you unshare your screen so we can?
Sorry.
There we go. So do we have any other questions? Well, thank you very much.
Thank you, everyone.
So our next speaker is Ben Wu. Ben is a fourth-year horticulture PhD candidate working with Dr. Meng Meng Gu and Dr. Hong Lin Quinn at Texas A&M University. His research interest focuses on plant breeding and plant insect biology to develop the integrated pest management of invasive insect pests. Additionally, he has been working on establishing callus-induced regeneration systems of ornamental plants for over 10 years. He recently achieved adventitious buds differentiation from the callus of queen crepe myrtle, also known as pride of India. And at this point, I will turn the floor over to you, Ben, and you can make your presentation. Thank you.
Thank you so much, Dr. Deffer, for the great introduction. It's Benwu from Texas A&M University. Today I will be presenting to A or not to A data question answered by real-time monitoring techniques for feeding mirror study of Kriegner bar scale. So when looking at my slides title, someone will wonder what Kriegner bar scale is, or why I need to focus on this instead. Well, Kriegner bar scale is a relatively new emerged insect from other countries. So it is an introduced one, exotic insect. It has very long and thin stylic bundles to suck nutrients from the plant. When feeding on the plant, it secretes honeydew. The honeydew leads to Blastidium accumulation on plant leaf surface or stem cell surface, as you can see here. As a result, the Blastidium accumulation physically interferes with photosynthesis, which can aggravate the reduction in flowering or fruiting of some plants like crepe myrtles or pomegranates. Since it was initially found in Texas in 2004, Kriegner bar scale has spread across 16 US states as well as Washington, DC in 2021. So this invasive insect spread so fast. And what's worse, besides the primary host, crepe myrtle plants, we observed the infestation of Kriegner bar scale on some economically important crops, as well as native species, such as Bear's black fig, Chicago hardy fig, Fuji apple, soybean, and American beautyberry. These observations indicated that Kriegner bar scale should be a polyphagous insect, which, heightened our concerns about its potential threat to the green industry and the ecosystem stability. So it was imperative to know more about this insect and figure out which plant will be the host, which one would not, so that we can minimize the application of host plants to better protect the green industry and ecosystem systems. So to do so, we did an experiment in 2019 to confirm hosts for this insect using 6 crepe myrtle species, 9 beautyberry species, 3 fig species, as well as California loosestrife. So attach the Kriegner bar scale infested branches to healthy plants, ensuring like 5 fresh ovisacs were inoculated on each plant. 3 weeks after the inoculation, we started recording and counting the number of new developed pupae and gravid females of Kriegner bar scale. If we observed an increasing number of newly developed Kriegner bar scale, we will say this plant will be the host. Unfortunately, all of the tested crepe myrtles, beautyberries, California loosestrife, and Wapahu fig were the hosts. But the good thing is, we got to know which plant or which species is under exposure to the infestation Kriegner bar scale. We spent 25 weeks, almost half a year, to accomplish this host confirmation experiment using like this conventional method. It was short of time consuming and labor costing. So we were looking for new methods to confirm a host rapidly. As you can see, let's take a closer look at our insect. This is Kriegner bar scale. Focus on this mouth part. It has a very long and thin stylic bundle. So we thought insect mouth part penetration in plants could be a vital parameter to assess plants as hosts. And luckily, we found that electrical penetration graph could track insects' stylic pathway in the plant in real time. So it would be awesome if we could establish this kind of system applicable for our insect study. So we established the EPG monitoring system to monitor the feeding behavior of our insect, because we think, okay, it will be like helpful to provide basic information about Kriegner bar scale and plant interaction from the perspective of feeding behavior. Our EPG system, as you can see, consists of the insect electrodes, substrate electrodes, an amplifier, a Faraday cage, laptops, and a stereo microscope. We can glue our insect on the backside to a gold filament, attaching with a copper wire, and we insert the copper wire into the insect electrode. After replacing the glued insect on the plant, we insert the substrate electrode into the potting substrate, turn on this device to start monitoring the feeding behavior. So, because this technique or this system is relatively new, so let me touch on a little bit how it works for our study. So, before insect probing, this EPG system is like incomplete circuit. So it is a flat line here, but once our insects start probing into the plant, then the EPG system, like the circuit, become complete. Once it's like when our insect using smelt part to poking or going the pathway into the plant tissue, we will be able to see different voltage fluctuations, termed EPG waveforms or feeding waveforms. So how to use this EPG monitoring system to rapidly confirm a host for our insect? So first step, we monitored the feeding behavior of our insect on the validated host for 24 hours. And we compared and analyzed 20 replicates of the datasets or the replicates for our insects with other hematogens feeding waveforms. We successfully identified 5 typical waveforms for our insect, as you can see here, including waveform C, waveform potential drop, E1, E2, and G. Each waveform represented a specific feeding behavior. For example, when our insect was doing like intracellular puncture or penetration in the plant, we detected waveform C here. Once the insect was puncturing this plant cells, we detect waveform waveform potential drop. I label number 2 here. And once our insect was like doing salivation and ingestion of phloem sap, we detected waveform E1 and E2 respectively, and waveform G when our insect was drinking xylem sap. So, okay, so all right, by the way, in general, we need to annotate or label our EPG recordings second by second manually. That was sort of time consuming as well. So we developed our programming based packages or applications to help us identify and extract the typical waveforms by reducing human input. And here's a more uplifting note that we have already released these EPG miner packages and the website version and the software version of each of the miner to the GitHub. And to our knowledge, this EPG miner was the first report on the GitHub regarding the identification and the extraction of feeding waveforms. It's free, so please do not hesitate to download it for your use if needed. Okay, so after finishing the identification and characterization of our insect feeding behavior, we compared the feeding waveforms across different plant species to check the differences using like a sumalimate as the pulse control. So we tested baby gem boxwood, creeping fig, wapahu fig, elephant ear fig, soybean, crane creep myrtle, and radish sample. The numbers in the parentheses represented how many data sets that we analyzed to compare the differences. Okay, here's something that we found very inspiring. So we detected all the waveforms on the confirmed host, like Sumanimian, as well as Crane, Crate Myrtle, and the Wapahu fig, which means Crate Barskill finished ingestion of phloem sap and xylem sap on their 3 species. So their 3 species should be the host. We detect all other waveforms except waveform E on creeping fig, radish apple, and soybean, which means that creeping barskill only took xylem sap but did not drink phloem sap from these 3. As you know, like the phloem sap is supposed to provide major nutrients supporting insects' growth and development. So our insect only took xylem sap, no phloem sap, which means it might not be able to complete its entire life cycle to produce partners, but it could survive for a while, having the likelihood to find a real host around. So we characterized, or we classified these 3 species as alternative hosts. Furthermore, we did not detect waveform E and G on elephant ear fig, and we did not detect any waveforms on baby Jim boxfoot, which indicate that creeping barskill did not drink phloem sap or xylem sap on these 2 species. So it would be reasonable to, to say, okay, these 2 species could be non-hosts for our insect. So that's how we answer to E or not to E question using this real-time monitoring technique for feed behavior study of creeping barskill. To sum up, we successfully established the EPG monitoring system applicable for our insect study. And we applied this EPG monitoring system to rapidly confirm hosts on the, based on the feeding behavior for our insect. And for future directions, we will test more economically important crops and native species using this system to better estimate or evaluate this insect's potential risks to the grain industry and ecosystems. Also, we would like to do the cross sections for our insects feeding on the plant to understand better how creeping barskill using its stylet penetrates into the plant. And also, we would like to combine the EPG monitoring system with an artificial diet to improve the understanding of creeping barskill and plant interaction from the perspective of feeding behavior. With that, last but not least, we would like to thank the 3 grants financially supporting my research. And with that, thank you so much for time, for attention, and I will be pretty glad to take any questions you may have.
Can you unshare your screen, please?
Sure.
Do we have any questions?
I'll kick something in. I got a question on the actually comment about the research on the xylem phloem aspect of it, which is critical for general pest control in the nursery industry, because some products are, basically xylem materials, and others are phloem materials, and people don't understand which feeding area those insects are focused on. So the information on the basic research we're doing is got other areas where it can expand to. So I think it's a great opportunity to
I think we lost him.
Well, I'll jump in there and ask my question. And I'm curious to know how easy it would be to apply this technology that you're talking about to other economically important pests or other scales, or if there might be other classes of insects that this technology might be more adapted to.
Thank you, Joseph, there for a question. So the question was how possible for our technology to apply for other insects for the industry. Well, this kind of monitoring system, I mean EPG, has already been applied for aphids, mealybug, thrips. So those are all very important economically pests. So I would say yes, this would be very, applicable for self-sucking insects. Did that answer the question? Thank you.
You guys are too quiet today.
Inwoo, it's Jim Robbins, University of Arkansas. Great presentation. And follow up to Mac's kind of question. Do you know how this methodology was originally developed? Where,
Well, yeah, like probably 7 decades ago.
Wow. Okay.
Yeah.
And was
yes.
it it was an entomologist that figured this out?
Yes.
Okay.
They developed this technique for, I think, for aphids primarily, for aphid study. Thank you, Dr. Robinson, for the question.
Hi, Bean.
Mm-hmm.
Is it possible to apply this technology to chewing insects?
Well, that's a good question. We can figure it out.
Yeah, that'd be interesting.
Because to my knowledge, probably chewing behavior will lead to like various voltage fluctuations, which probably sometimes cannot be identified or characterized as sort of specific, meaningful feeding waveforms. But let's see. Yeah, that's a good question.
Yeah, thank you.
Mm-hmm. Thank you.
And Benwo, Jim Robbins again, just a real quick, just trying to better understand this technique. So you using a water-based glue, I think, attached an electrode to the back of the female, I guess, the adult female.
Uh-huh.
And then where is the other, because you're completing a circuit, where is the other electrode? Is it on the petiole?
Yes. Oh, well, so the question was, what's the another electrode inserted, right? So first electrode, I insert my insect into the insect electrode. Another electrode we term as substrate electrode. So we insert that electrode into the potting substrate or into the soil. So plant, insect, soil, or just plant insect, soil. That would be the, or substrate, that would be the, could be the circuit if the insect penetrates mouth part into the tested plant.
Thank you.
Thank you.
Do we have any more questions? Well, that's absolutely fascinating. I'll have to remind my students that there's a reason for them to take physics. Well, that concludes our 3 presentations. We've had a few judges listening in. They're going to be sending their scores to me. And as Bree told you before, we will be unveiling those winners at the conference. So at this time, I'm going to say thank you to all of the judges, particularly those of you that I volunteered without you knowing it until the last minute. I really appreciate your help. And thank you to all the students. You all have done a great job making us once again look very good from our end. So Bree, I turn it over to you. Thank you.
Well, thank you, Mac, and thank you to all of the students for your active participation this year. And I want everybody to stay on because we have one more very special program. And this is featuring another one of our outreach programs that connects to early or young professionals. The Early Career Professional International Exchange Program is a unique opportunity awarded to IPPS Southern Region members aged 35 and younger, or members who are new to the industry. This professional development experience truly is a once-in-a-lifetime moment to travel to the European region and attend their annual meeting and extended tours. As the 2014 recipient, it is fair to say that this experience enriched my career in many ways and has led to lifelong friendships with plants people from across the world. I'm in regular contact with my Danish friends who I visited when I was there. We look forward to offering this program once again, fingers crossed, in 2022 when travel is a bit easier. So be sure to join IPPS Southern Region to become eligible to apply. Remember, we have free student memberships that you can fill out directly from our website. It is an honor and pleasure to introduce our next presenter, a longtime IPPS member, a student research competition winner, several times Vivian Monday Scholar, and most recently, the Southern Region Exchange Representative. Shay Keene is a PhD student in the Environmental Horticulture Department at the University of Florida. She completed her master's degree in December of 2017 and dove immediately into a doctoral program. Shay's research interests include floral, volatile analysis, and consumer preference studies. Now, on a more personal note, we all met Shay, whether we knew it or not, during our 2015 tour in Florida while she was working at Bach Tower Garden. The following year, I had the pleasure of getting to know Shay better as we shared a hotel room during the Virginia Beach meeting. And I was so impressed then, and I continue to remain in awe of your knowledge, your compassion, your determination. Shay, I can tell you that your IPPS family is very proud of all that you have already achieved, and we know that you have a very, very bright future ahead. And thank you for being an exemplary representative of the Southern region during the 2019 exchange program. So with that, we would love for you to give us a synopsis on your tour. And I believe you have given us already a pre-recorded session.
Yes, do you want to say hello or just go ahead and play?
Yes.
I'll just say hi real quick. I'm so excited to be here and so grateful to have, been the 2019 IPPS representative. And yeah, if you guys want to go ahead and play the recorded presentation, that would be great.
Hold on. It wanted me to do a new setting, so fingers crossed. Please keep me updated on the sound.
Hello, everyone. My name is Shay Keene. I am a PhD candidate in the Environmental Horticulture Department at the University of Florida, and I've been a member of the Southern region of IPPS since 2016, which was the first time I attended an annual meeting as one of the Vivian Monday Work Scholars, and that was the first time that I heard about the Early Career Professional International Exchange Program. At least up until the pandemic, this was a program that the European and Southern regions did each year, where each one would send a representative to the other region to tour nurseries and gardens and attend the annual conference. I applied for the program for the first time in 2017, wasn't selected. I applied again in 2018, wasn't selected, but the third time is the charm. And in 2019, I was chosen to be the exchange program representative. And this presentation is my long overdue report on my exchange program experience. So in 2019, the European Region Conference was in Stratford-upon-Avon. So from October 2nd through the 8th, I toured nurseries and gardens in the southeastern part of England while being hosted by Tim and Annette Lawrence Owen at their home in Chichester. On October 8th, we drove about 3 hours up to Stratford-upon-Avon, which is where the conference was held, and the conference itself was October 9th through the 11th. I stayed an extra night in Stratford and then the next day traveled to London, where I spent the last few days of the trip on my own, which was my first time ever traveling solo. And I flew back to Tampa on October 15th. So I took an overnight flight from Tampa to the London Gatwick Airport. Unfortunately, I was really excited and ended up just not sleeping at all on the flight. And so I arrived at the London Gatwick Airport feeling pretty exhausted and a bit disoriented. But Tim picked me up from the airport and we had about a 1 hour drive back to his home in Chichester. And as soon as we got on the road, the first thing that I noticed was all of these amazing hedges everywhere. There were these just tall, thick, lush hedges running along the sides of roads and dividing up fields and bordering houses. They were everywhere and I loved them and was immediately just enchanted by them. But on the way, we stopped in the historic market town of Arundel. They had a really neat cathedral and medieval castle. And once we got to Tim's house in Chichester, I just was so exhausted, I ended up taking a 4-hour nap. But then after that, I got up and I had my first official afternoon tea with Tim, and he showed me around his backyard garden and his amazing greenhouse that he had bought as a retirement present for himself. And that night we went on a walk, and this is just a picture of one of the many beautiful, lush green rolling fields that I saw while I was there. So we started my horticultural tour at the nursery that Tim had just recently retired from, Wolverton Nursery. And Wolverton is one of 3 nurseries in a cooperative of businesses that are collectively called Tristan Plants. Wolverton mainly grows ornamental plants, but they have a long-standing and active breeding program, and they frequently release new patented varieties. So we started out at their propagation nursery and were given a tour by the propagation manager, Paul Dyer, shown there in the left photo. We then drove a short distance down the road to Wolverton's main nursery, which was in a large complex with the other 2 nurseries in the cooperative. And it was at Wolverton's main nursery that I started to realize how few of the ornamental plants I recognized, because the ones that they grow there just don't grow in Florida's hot and humid climates. And even the plants that I hypothetically did know, like hibiscus, looked nothing like the tropical hibiscus that I'm accustomed to. But we had coffee break with the managers and then walked over to Benstead Nursery. They grow a lot of herbs, but also grew some alpines and succulents and perennials. And then from there, we walked over to Fleury Nursery, and they had just recently acquired that production site from a nursery that had gone out of business. And it was a little bit rough. It hadn't been updated in a long time, but there were plans to invest in some much needed renovations now that it had been acquired by Tristan Plants. One of the last stops on our tour was the Finishing and Dispatch Center, which served all of the nurseries in the cooperative. And it was this huge, vast warehouse space, which on dispatch days would have been full to the brim of people and plants. But when we visited, it wasn't a dispatch day, so it was mostly empty. The next stop on my horticultural journey was the Royal Horticultural Society, or RHS, Garden Wisley. And Wisley is the RHS's flagship garden. It's one of 5 that they own and operate, and it's the second most popular garden in the UK after Kew. I have to say though, I think Wisley might have been my favorite garden of the whole trip. It was just really incredible. Right after we got there, we met up with Chris Moncrief, the head of horticultural relations at Wisley, and he gave us a tour. He took us to the construction site of the RHS Hilltop, which was a dedicated science center for UK horticulture. He showed us the new children's garden that had been designed by Catherine Middleton, and he took us through the glass house, including some of the behind the scenes areas. And it was in the glass house that I finally started to see plants that I recognized, because a lot of them were, tropicals and subtropicals. But we had coffee with Chris, and then he left us to explore on our own. I really enjoyed Wisley's fruit collections in their orchard. They had some great espaliered trees, and I was able to see some fruit trees that I don't normally see, like apples and pears. Wisley also had a really great collection of bonsais, and this is just a few of the many that they had. The next day, Tim and Annette took me to tour historic Chichester, which I hadn't known this before I went, but Chichester had been a Roman settlement as far back as 43 AD. So we went to a cool museum that had been built on top of some ruins, and the middle of the museum opened up looking down into those ruins, and they had some great Roman mosaics. And then also around Chichester, part of the original Roman wall that surrounded the settlement still remained. And so you could walk along that, and it provided a great view into people's long and narrow backyard gardens. The next day was just a full day of homework and practicing my presentation for the European Region Conference, so no photos of that. But on Monday, the 7th, we toured Vitacress, and Vitacress is one of the leading producers of leafy greens and herbs for UK supermarkets. I don't remember exactly how large the production facility was that we visited, but it was massive, and it was entirely indoors. It was at Vitacress that I first started to learn that the UK and the EU have much stricter pesticide regulations, and there are a lot of conventional pesticides that we use here in the US that they can't use over there. And the rules are especially strict for edible crops. So rather than relying on conventional chemical controls, Vitacress had very strict cultural management practices and disease control programs, and they also used some biopesticides and other biological control agents. And they also had some really impressive automation and equipment there too. The next day, I said my goodbyes to Annette, and we started the 3-hour drive to Stratford-upon-Avon. On the way, we picked up this gentleman named James, and he was one of the six packers for the conference that year. And the six packers is basically the European region's equivalent of the Vivian Monday work program. They select 6 young people, which is why they call them six packers, to work at the conference and help with registration and those sorts of things. So we picked up him, and then we stopped along the way at West Dean Gardens, which is the garden on an old English estate manor home called West Dean House. And obviously it's hard to compare a garden to a place like Kew or Wisley, but honestly, I absolutely adored West Dean, and it was one of my favorite gardens of the whole visit. It was pure English. They had these beautiful rolling green hills dotted with sheep grazing, and they had these lush cottage style gardens, and they had a sunken garden and a walled garden and more espaliers, and obviously some great hedges too. So it was really, really beautiful. The house itself was undergoing a really major roof restoration, so it was unfortunately covered, but they also had a really neat exhibit there that had this old-timey horticultural equipment like these sprayers and mowers. So we arrived in Stratford in the late afternoon on the 8th. I was introduced to Carl O'Neill, the site chairman and then VP of the European region, and the rest of the six packers. I helped them put together the conference packets and name tags and whatnot. And then that evening, the conference committee members, six packers, and some of the other early arriving members, we all went and had dinner at this great restaurant right on the River Avon. So the conference itself was the 9th through the 11th. It was structured with presentations in the morning, all 3 days, and nursery tours in the afternoon on October 9th and 10th. The theme was technical times, and many of the presentations centered on the growing number of challenges in the UK. And it was, just a quick aside, it was a pretty tumultuous time in the UK because it was right in the middle of the Brexit negotiations. They had already delayed the withdrawal a couple of times, and there were some pretty important parts of the withdrawal agreement that still were being worked out. So it was really interesting to speak with the different members about Brexit and hear the different opinions on it. And I'm curious to know if any of those opinions have changed now that they're on the other side of it. But as far as the presentations go, like I mentioned earlier with the stricter pesticide regulations, there were a couple of presentations about developing biofungicides to replace fungicides that couldn't be used anymore, and one that about helping growers get the most out of biopesticides to sustainably protect their crops. Another one was on a topic that's relevant to US horticulture, trying to find a suitable replacement for peat and developing peat-free blends. And actually, I just learned the other day the UK is going to be banning the sale of peat-based media in garden centers starting in 2024. There were a couple of presentations about using technology to improve efficiency and reduce inputs, especially when it came to things like water and fertilizer use. And there was also a cool presentation about the future of plastics in plant production, and which covered the development of this standard recyclable nursery pot in the UK. The issue with the standard black nursery pots that we're all familiar with is that they aren't accepted by most curbside recycling programs or even large recycling centers because the black plastic can't be seen or detected by the infrared sensors that are used at recycling centers to sort the different types of plastic. So they developed this taupe-colored polypropylene pot, which can be detected by the sensors and thus is at least hypothetically recyclable. I also gave my presentation the first day of the conference right before lunch, and it was perfect because I was able to introduce myself as the exchange program representative and give some of my academic and horticultural background to everyone at the same time. And so it just put me in a unique position of being known to everyone at the conference, which really made it easy to get to know the members. And it was a smaller conference, smaller than our southern region. There were maybe 100 people there, give or take. So at the end of it, I think I'd literally spoken to everyone at least once. We started our nursery tours at New Leaf. They specialized in climbing plants, and we had a wonderful canine companion named Bella who very excitedly greeted us right when we got there and stayed with us on the tour. And I was impressed with their commitment to growing all those climbing plants, because just the thought of trying to keep them from becoming an entangled mess was a little bit stressful. But from there we went to Newey Avencross. It was one of several nurseries in a larger group called the Newey Group, and they were commercial contract growers of bedding plants. Their nursery was incredibly tidy and orderly, which was rather soothing after the controlled chaos of New Leaf. But at that time of year, they were pretty much only growing violas and pansies. The next day, we toured Borden Hill, which is part of Ball Colgrave, which is Ball Horticultural Company's leading wholesale distributor in the UK. They grow. Facilities were huge, and like Vitacrest, basically the entire nursery was connected by tracks so that benches could be moved from one part of the greenhouse to another as needed. There was a very effective use of information systems and technology. Every tray and container was tagged with a barcode and tracked throughout its production life. They had high-tech sensors all over the greenhouse, and they had a color-coded labeling system that provided important information to growers and staff at a glance. They also had some of the most impressive equipment and automation that I've seen at a nursery. They had a machine that filled trays with media, one that sowed seeds, but then they had this other one that once a tray of seeds had germinated, it went through the scanner and it detected any empty cells, like if a seed hadn't germinated. And then it would go to another part of the machine and it would send up these little blasts of air directly under whatever cells were empty to blow out the media, and then this other machine would replace it with rooted plants and fill in the gaps. It was so amazing. And then they had another one that transplanted, young plants from trays to larger containers. And I just stood there and I watched it for probably 5 minutes because it was mesmerizing. So the last nursery we toured was Hawksmill Nursery. They grew over 1,000 varieties of different perennials and vegetables and herbs and grasses and ferns. And they also had just finished building this brand new glass house, and it still had that sparkly new feel to it. And it was really neat just seeing so many different types of plants being grown in one production space. So on the final day of the conference, it was just presentations in the morning, and then we all had lunch together before saying farewell. And it was, bittersweet saying goodbye to everyone, because I felt like I really got to know some of the members just in the past few days. But saying goodbye to Tim was the most bittersweet because he had been such a wonderful host and guide for the first part of my trip. But he had to get home to Annette, so we said our goodbyes, and then I was on my own. Which I'm a really introverted person. So after 10 days of constantly meeting new people and networking and interacting, it was nice to, have a little bit of time to myself. So I stayed an extra night in Stratford. I saw Shakespeare's birthplace, and they had these great statues of Shakespeare's characters. And, I walked along the River Avon, and it was just a really lovely evening. But the next day, I basically spent the entire day on different charter buses making my way to London. Even though it was a whole day of traveling by bus, it actually wasn't that bad. And I got to see parts of England that I probably wouldn't have seen otherwise. But I arrived at my Airbnb in Hammersmith in the late afternoon, and a lot of the museums and places like that close at 5. So I decided to just take it easy and get an early start the next morning. But on a whim, I decided to look up the play Harry Potter and the Cursed Child, and amazingly, they had very reasonably priced tickets available for a show the next day, so I bought them. But in the morning, I got to the Natural History Museum right when they opened at 10, which was later than I would have thought they would have opened. But so I only had about an hour and a half to spend before I had to make my way over to the theater where the play was, which is hardly enough time to see anything in a museum that large. So I basically just had to pick one exhibit I really wanted to see, which ended up being the Hall of Minerals and the jewel collection in the vault. But the theater that the play was at was too far to walk. It was in the Westminster Borough. So I left the museum and I hailed a black London taxi cab, which I felt kind of fancy doing, and made my way over to the Historic Palace Theater. It was an absolutely beautiful theater, and I could not believe how amazing my seats were. No one tall sat in front of me, and I wasn't that far from the stage, and it was an incredible play, and I cried at least twice. So on the penultimate day of my trip, I toured Kensington Palace in the morning, and they had a really neat exhibit celebrating the 200th anniversary of Queen Victoria's birth. And then that afternoon, I made my way over to the Royal Botanic Gardens Kew. One of the six-packers from the conference, Charles Shee, was doing an internship at Kew at the time, and he had offered to give me a tour. So I met him at one of the staff entrances, and he let me in the side gate and gave me a tour, and we had lunch, but then he had to prepare for a lecture later that day, so he left me to explore on my own. And I really enjoyed seeing the iconic Palm House. It was amazing, and the Temperate House was great too. There was a Jubilee exhibit going on at that time, so there were beautiful glass sculptures scattered around the garden. And the Princess of Wales Conservatory was really amazing as well. It's divided into 10 different climate zones, and each one is filled with plants that are unique to that climate region. But there were a couple of plants that I saw growing on purpose at Kew that really surprised me. In the Princess of Wales Conservatory, they were growing cat's claw, and that became like my arch nemesis when I worked as a gardener at Bok Tower Gardens, and it's a Category 1 invasive in Florida, which is the worst kind. And then in the water lily house, they had what some people called balsam apple, but I've always called stink vine, and it's a Category 2 invasive in Florida. But I guess, one person's invasive weed is another person's botanic garden specimen. So there you go. But on the last day of my trip in the morning, I went on a 1-hour horseback ride through Hyde Park. I was and always will be a horse girl. And so riding and cantering through Hyde Park was absolutely magical. But as soon as that was done, I had to rush back to my Airbnb, get my bags, and head to the airport. And just like that, my trip was over. But just in closing, I'd like to say just a few more things about my exchange program experience. I don't want to get emotional, but words cannot adequately express how deeply grateful I am that I was able to go on that trip. Every part of it was incredible and wonderful. I met so many incredible people. I saw so many incredible places and things. I learned so much about the horticultural industry overseas, and I made memories that I will cherish forever. It was truly a priceless, once in a lifetime experience, an absolutely invaluable gift that IPPS gave to me. And then when I think about how just a few short months later, the whole world changed, words can't even begin to describe how lucky and blessed and thankful I am that I was able to have those experiences before COVID changed everything. I am so, so grateful for IPPS and its support of the exchange program. And I sincerely hope that as soon as things return to some semblance of normal, that the Southern and European regions will resume the exchange program, because it is truly a program worth supporting. So thank you, IPPS, for everything. And thank you for listening. I've really enjoyed reminiscing about the most amazing trip of my life. Thank you so much.
Thank you so much, Shay. That was so nice to escape across the pond for a few minutes, since we haven't had the opportunity to do so. Does anybody have any questions that you'd like to ask Shay specifically about her experience or about the exchange program in general?
Shay, thank you for an incredible presentation, and clearly you're a worthy, individual to go. And just a fabulous presentation, and I'm glad that you had a wonderful experience. I've got 3 quick questions for you. In general, do you feel that most of the nursery production you saw in the area where you were is covered production? Is question number 2. And number 2 is, at Vitacrest, is all of their leafy green production on a horizontal, or did you see any vertical production, as we're doing more of here in the US? And
So so at Vitacrest, I didn't see any vertical production. It was all horizontal. And as for the covered production, it was, a lot of it was protected and covered. There was a little bit of like ornamental plants were grown outdoors, but I definitely saw a lot more, indoor protected production than what I've seen, in the southern US.
thank you. And again, great presentation.
Thank you. It was, it really was just the best trip I've ever taken in my life, and one of the most meaningful experiences I've ever had. Every time I practiced my presentation, I would cry at the end, because it just, even now, almost, 2 years later, it blows me away that I was able to do all that. It was so wonderful.
Well, if nobody else is going to ask, I've got a third question. At Binstead, there was something odd I noticed in the photograph. There was a pattern in the where it looked like they left the tray out but there was a pattern to it looking across the beds, and I was wondering if there was an irrigation riser or something, but do you know what I'm referring to?
Yes, I just checked my pictures real quick. I don't remember, I don't think that there was like an irrigation thing. It might have been more so for like insect traps, because there weren't any in that photo, but I know that I saw in other parts of the greenhouse where they would have, in those spaces, like sticky traps or that sort of thing, or even, like when they would use biological control agents, having, little, whatever, the nest for the little insects to be in those spaces. So it might have been something like that.
It's so we visited there on the IPPS tour in 2017, and I remember real clearly because I love that grower so much. But there was a Polish woman named Daria. I don't know if she was still there when you went, and she showed us like they would use those to move around in the beds, like that was for the grower access. So they would use that for, and it makes sense that they would put their sticky traps there or whatever, and they would just kind of jump around in there and mess with the plants. But it was really. She was so cute when she demonstrated it. It was just so fun.
Thank you, Laura.
Yeah. But it was so much fun for me to go with you back to some of those places and to see Tim and Tim and Annette are lovely people.
They are absolutely just the best. I love them both so much.
Yep.
Okay.
I'm sorry, Judson, I'll let you say it, but for all the students that are on here, apply for the exchange. You'll never have a better chance to see a different part of the world with wonderful people and see the things that you're going to want to see because you're all, into this. So it's really a great opportunity.
Yeah, I actually had to cut down my presentation by like almost 15 minutes because I just had so much extra stuff in there, and I went back to my emails and I'm like, oh, it's supposed to be 20 minutes, not 35 minutes. So I started like deleting slides and stuff, but yeah, I mean, like I said, at the first conference, that was when I heard about the exchange program for the first time, and I was like, oh, this is something that if I can do it, I want to do it. And yeah, absolutely. Like get involved in IPPS. Like I said, the first 2 years I applied, I didn't get selected, but I, got more involved and I participated in the student research competition and just got to know the members more. And all of that was amazing too. And just then being able to go on the trip, it was incredible. Highly recommend, 100%.
And to update everyone, we will be hosting the international meeting in 2023. And our ultimate destination will be landing in Durham, North Carolina, but the international tour will begin in Washington, D.C. And Tom Saunders is doing a fantastic job getting the tours already set up. In fact, he texted me bright and early this morning that he and Lynn are going to start driving the route next week. So we're going to be well prepared for hosting the international meeting. And that is a time when we hopefully will have an European member visiting us. And that's how the exchange works back and forth. We highly encourage everyone really under the age of 35, or if you're new to the industry, to take advantage of the many programs that IPPS Southern Region offers so that you can have these worldwide experiences. It's one of the great things that an international society provides its membership. And I have never met anyone in the exchange program who didn't leave feeling like they have an extended family in a different part of the world. Well, everyone, in closing, I would like to thank you all for attending the Charlie Parkerson Student Research Competition today. I hope you found the programs helpful and inspiring and took as many notes as I did. Remember, the winners from today will be announced during the awards banquet held on Monday, October 25th, live and in person from our annual meeting in Mobile, Alabama. We will begin live streaming the full awards banquet starting at 7 p.m. Eastern through the IPPS Southern Region Facebook page. So please tune in if you are not able to be at the meeting in person. I want to thank everyone who has registered for our meeting. We have reached our limit for what the hotel had set, and we have wonderful sponsorship support, and even through these very difficult times, IPPS Southern Region is certainly leading the society with regard to financial stability and increased membership. And that is all because of active participants like all of you. And it's been a real honor to represent this society for the past 2 years. We hope you enjoyed today's sessions, and we look forward again to having these student competition live and in person next year at the 22 annual meeting in Athens, Georgia. Mark your calendars now, October 17th through the 20th. Remember, that's a Monday through Thursday schedule. And I thank you all for participating today, and we look forward to announcing the winners and seeing you live and in person in Mobile. Be safe, stay well, have safe travels, and have a great weekend, everybody. Oh, plant auction. Thank you, Martin. Martin, do you want to give the plant auction nudge?
Yeah, absolutely. Yeah, it's going to be an exciting plant auction. It always is. It's probably one of my favorite parts of IPPS. Just want to encourage everyone to bring your best goodies and down to Mobile, Alabama. If you can't come, you're more than welcome to ship the plants to Vandergeest Nursery in Sims, Alabama, and I guarantee that most of them will get to the auction. Well, some of them will get to the auction. So look forward to seeing you guys in Mobile.
It's going to be a great meeting. Our local site committee, chaired by Dr. Jeremy Pickens, has done an outstanding job covering all their bases. We look forward to seeing everyone in person. And I again want to extend my appreciation to Dr. Cheryl Boyer for being the lead on all of this virtual experiences that we've been going through for the last 18 months. And to Dr. Mac Thetford for your leadership in keeping this student competition so well organized. And to Charlie Parkerson for being the brainchild behind this. It's a very unique element that Southern Region offers. And I just think that we have a million reasons to be proud of IPPS Southern Region, and this is at the top of the list. So thank you all so much. Do we get to chat now and like actually talk to one another?
I thought Charlie might want to say something.
I know.
Charlie, where'd you go?
I can end the recording, but I thought you might want to say hello on the recording.
No, I'm just glad to be with you. I enjoyed IPP. It's been such a big part of my life, and I just really appreciate all the work you're doing. Mac, right on down the line. So God bless you all.
All right.
The numbers in Mobile meant that I didn't really need to be there. Folks need to be there, like the students that are coming. So I'm going to be in Mobile, and I hope to see you on the tours, but I'm not going to be at the meeting. It'll be the first one I've missed in 45 years.
I think it's safe to say, Charlie, that even if you're not there, you're there.
Yep.
Thank you. Y'all be good. I missed my nap time this afternoon, so I'm going to take my nap now.
All right, Charlie, it's good to hear from you.
See you later.